Hey guys, this is the 4.1 video, and we're getting started talking about patterns. This is easy, but we're building up to something a little bit more difficult. Okay, and the first two sections of this chapter are pretty easy, and then it starts to get harder. So in your textbook, it's having you look at this pattern and then describe what's going on with this pattern. Okay, so we see that it's getting smaller and smaller and smaller, and what I see happening is that one of the dots on each end is disappearing each time. Okay, at each arm of the plus is losing a dot each time. Okay, each figure has 4 fewer dots than the figure before. Okay, the next 3 figures of the pattern would be, okay, we've got a center, the last one I see is a center dot, and each arm has 3 dots. So the next ones would look like this. Okay, 2 dots on each, the center dot plus 2 dots on each arm, the center dot plus 1 dot on each arm, and then finally just a center dot. Okay. Then it says write the sequence numerically to represent the number of dots in each of the first 7 figures. So down here at the bottom, you can see that it started out, the first picture had 25 dots in it, then 21, then 17, then 13, then 9, then 5, then 1. Okay, so we're going down by 4. I didn't mean to do that. The next sequence, okay, Jessica's investigating her family tree by researching each generation or set of parents. This is a mouthful. Here we go. She learns all she can about the first 4 generations, which include her 2 parents, her parents' parents, her parents' parents' parents, and her parents' 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 parents. It's crazy. Think about the number of parents and describe the pattern. Okay, well, if you think about it, each generation has 2 times the number of parents as the generation after that. Here's what I drew in class. In class, I drew like kind of a family tree. Okay, so I started off, well, let's move that so we can. I drew like the parents, all right, then each of them had a parent, then each of them had a parent, and then each of them had a parent. Had 2 parents, I should say. Had parents. So each little dot represents a person. Okay, so we have the first generation that had 2 people in it. The second generation had 4. Then 1, 2, 3, 4, 5, 6, 7, 8. And then these little dots here, that's 16. So determine the number of parents in the 5th and 6th generation. We would just continue or seem to be multiplying by 2 every time. The 5th generation has 32 and the 6th has 64. So the numeric sequence, I've already kind of written it on the side here, is 2, 4, 8, 16, 32, and 64. Okay. Next we've got some squares. Analyze the number of squares in each figure and describe the pattern. Okay, so what we notice is that each set of squares we're getting smaller, and what we're really losing is we're losing the top row, and the side row. Okay, then we're losing the top row and the side row and the top row and the side. Each time, that's what we're losing to get to the next term. Okay. The number of small squares is decreasing by perfect squares. So we've got our sequence. Wait, why can't I see the whole thing? So we've got our sequence, got the next three figures in the sequence. Okay, a 7 by 7, 6 by 6, 5 by 5, 4 by 4, 3 by 3, 2 by 2, 1 by 1. So 49, 36, 25, 16, 9, 4, and 1. Here's the omelet one. I'm going to show each one in the sequence. I'm not going to talk about each one, but if you wanted to pause and read each one to help you, you can do that. So I'm going to show each one, pause so you can read it if it's one that you don't understand, and then you can go on to the next one. This one is really similar to the collection of squares, except this time the number of squares is increasing instead of decreasing. So it's the same numbers, 1, 4, 9, 16, 25, and 36, but it's increasing. Again, you can pause and read these. Here's our troop of triangles. Now, when I did this in class, I kind of helped kids out by color coding the triangles because it helped them use words to describe what was happening in the sequence. So every figure has one more row of triangles, and that row has one more triangle in it than the previous row. So these are the next two. I bet that was good fun drawing that. Okay, so the first diagram had one triangle in it, then 3, then 6, then 10, then 15, and then 21. It had 21 colored in triangles. Here's the one about gamer guru Micah. He's getting 50 more points for each mini game he plays. This one I thought was pretty easy. Polygon Party. You're starting off with 3 sides, then 4 sides, then 5 sides, then 6 sides. So we're adding 1 side every time. And that was super easy. 3, 4, 5, 6, 7, 8. This one was tricky for some kids because somehow they figured the 6 has to be part of it. But really 6 has nothing to do with it. It was just a little bit of interesting trivia. Jacob's Pizza was 6 foot in diameter. Well, isn't that neat? That's taller than Mrs. Andrews. I'm only 5'6". That would be a pizza that be bigger than me. Okay, so go ahead and pause it if you need to read this. Okay, so then in your textbook there's this chart, and this is going to become important for the next lesson. I'll come back to this chart for my 4-2 video. Okay. So I want to talk about a couple vocabulary words here. We've got infinite sequence and finite sequence. And it's just what it sounds like. An infinite sequence is going to go on and on forever. There's nothing that limits that sequence. A finite sequence is one that there's a limitation for. For example, in your textbook when we were doing the dot one, there are only so many dots I can take away. Okay, this is a finite sequence because I have 49 and 36 and 25 and you know, and so on until I get down to one dot. I think I just said the wrong numbers, didn't I? I did. 25, 21, 17, 13, 9, 5, and 1. So I'm going, the point is that this is a finite sequence because after this single red dot here, I can't take 4 red dots away anymore. Okay, so that would be a finite sequence. However, let me scroll here. Family tree is more of an infinite sequence because, you know, everybody has parents. Okay, if you trace back another generation, then they have parents. Then you trace back another generation, and they have parents, and they have parents, and they have parents. Okay, so you get back to like caveman days and stuff like that. The squares. This is a finite sequence. Again, I can only take away so many squares before I get down to where I can't take any away anymore. Al's omelets. He has 150 eggs. He's taking 3 or 6 eggs away after each omelet. He's going to run out of eggs. This is a finite sequence. If Mario had an infinite number of mosaic tiles, he could make his mosaic tiles forever. Okay, so the only reason we could say that Mario's tile thing is finite is because he will humanly run out of space and tiles to work with. But mathematically, it's infinite. Triangles. We could keep drawing triangles forever. Okay, that is an infinite sequence. Okay, and so on. Alright, so that is the main idea that we wanted you to get out of 4.1. And good luck on your homework, and we'll see you next time.